All right, bye-bye.
Have a good evening.
You too.
Now, for your main divisions, those are going to be your numbered divisions. So the largest division that we have, it's in terms of 1 volt. So the gap, the labeled gap is 1 volt, 1 volt. Main division's 1 volt. Now, if we talk about the smallest division, let's take one of these main divisions. Now they're divided up in the 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 smaller portions. So we're going to take the main division divided by the 10 portions. We'll get 0 or a tenth, 0.1 volts. So any questions about that? So let me switch over. So this is a part where I definitely want to switch over to document view. All right. So one of the tricky things with this, and this comes up every semester, is actually how do you read these things? And so reading it can be kind of tricky. So if you take a look, say like C. So if you're following along, it's page 353. And let's take a look here. Yeah, page 353 of 5.5. And okay, this one, if we take a look at our main divisions, they're going to be 10 units of 10. We have a range of 100. And we have a smallest division of 5. So taking a look at A, this looks like it's going to be 5. And this one looks like it's 25. C and D, what do you think about C and D? Well, C, they kind of, it looks like it's almost perfectly in the middle of the 40 and the 45, but the text says it's going to be 43. They're going to call this 43. And then for D, kind of the same thing. You take a look at this, it's like, well, I mean, that could be like 77.5, but they're actually going to call this 78. So some of the readings on this, when you get to those, it might be a little tricky. Just sort of letting you know. So you have to kind of eyeball it as best as you can. Yeah, you can see this is where they have 43 for C and 78. So you can take a look, try to figure out what these are. Now, here's something, I'm just going to show you from the text here, and then I'll draw something out here. But this is what's called a non-uniform scale. And so the idea of a non-uniform scale is that you have, okay, this is like 0, 1, 2, got some smaller divisions in here. And then the magnitude starts changing. So let me switch out of this. All right. So non-uniform scale. So what we could do, I'll construct it kind of how they did. So this is going to be 1, this is going to be 0. You can go 1, 2, 3, 4, 1, 2, 3, and 4. Now what's going on here is we have 0, 2, and 1. So it looks like our main scale, based on labeling, here it's going to be 2. But then our smallest scale, well, this is 1. So it's divided into 1, 2, 3, 4, 5. So it's going to be 1 divided by 5, or 0.2. So that's one way this goes. Now let's change it up a bit. Now for this part, now the main scale, or the main division rather, now it's going to be 1. So 2 to 3 to 4 to 5. And the small, well, that's that smallest unlabeled one. So this is a unit of 1. So we take 1 divided by 2. You get 0.5. Then we have this one. Now for this, the main scale, we're now counting by 5s. So you have 5 here for the small. The 5 divided by 5, or 1. We'll go a little. And then we have let me go one more. Here, look at 55 here. And then finally over here, we have 55 and 15 that are labeled. So that's going to be 40. And then we take our small. 40, we have 1, 2, 3, 4, 5, 6, 7, 8. And we're going to get 5. So for your non-uniform scale, you're going to get changes in your main and in your smallest divisions. It's just something to kind of be aware of. You could accidentally make a, especially when you're transitioning from one version of the scale to another, it's easy, you can make a mistake and misread something. All right, so any questions about that? right. So the next thing that comes up circular scales. And where you typically see these, like for non-uniform scales, you'll see those like in ohm meters. This is something you'll see, say, for cubic feet of water. And so something that you might run into, let me pull up the book here because I think they're going to do a better job drawing it than I am. Well, I'll do an example. I'll do a simple example. Well, let's say we have something like this. So a circular scale. So we could have, say, not quite like a clock. You'll see like something like this. And let's say this is hundreds. There's another one in here. 0, 5, 1, 2, 3, 4, 6, 7, 8, 9. Now, usually they're more complicated than this. You'll have more. And we'll call this the tens. So what you might see is a gauge like this, and you might see it will give it an exact reading. So the thing is, how do we do this? Well, when we read it between two numbers, the way you can think of this is that it's reading in hundreds. So this says it's between 100 and 200. Then there's some extra space. It's not as low as 100, but it's not quite the 200. So we got to measure this extra space. Let me get a little more accurate how that's going to go. Let's say we're going to point this at the 4. Point it at the 4. So we've made it to 1. We're past 1. Didn't quite make 2. And so this extra space here, we're going to read this on this scale here. So what we typically do with these is when we have this between, the needle between two numbers, we read the smaller number. Now there's an exception to this. If a needle is between 0 and 9, we read the 9. This is the one exception to this rule. And the reason's going to be this. If this thing goes around and then stops between the 9 and the 0, technically here, 9 is the smaller number. This is becoming a 10. So in this case, we treat 9 as the smaller number. It's another way of thinking of it. So any questions about that? So for this meter, we would have 1 times 100 plus 4 times 10, or 140. So another kind, and I'm going to do a couple examples here. Let's take a look at another one of these. One a little more complicated, and you have to excuse some artistic license. And let's say we have 6, 5, let's make this 10,000. And we've got our needle between the 6 and the 5. Now let's say here, another one, I'll make this 100,000. We have an 8 and a 7. Let's put our needle between those. We have 1,000. Our needle between 8 and 9. So here we have 100. 2, 3. Put our needle between the 2 and the 3. So we have a tens. Zero and 1. And then finally, we have a 1. It's a little bigger. Point the needle at 4. So how do we read this? Well, let's take a look at the 100,000. It's between 8 and 7. So for the 100,000, we're going to go with the smaller number. Then for the 10,000, we're between the 5 and the 6. So we'll go with the 5. For the 1,000, we're between the 8 and the 9. For the 100, we're between the 2 and the 3. So again, we're going to go with the smaller number. Now for the 10, we're between the 0 and the 1. So we're going to go with 0. It's only between 0 and 9 do we choose the number, because 9 is technically smaller than 0 because 0 is acting as 10. And then finally, we have 4 times 1. And if you perform these operations, we get 758,204. So any questions about that? So the last thing to mention in this section, I think this will be as far as we get tonight. We'll finish this section and that's going to be it. It's a complicated section. There's a lot to it. But we're going to talk about what's called a metric dial. And this is for measuring very tiny distances, very tiny. So for example, say a difference in height across a flat surface. So is there just this oh so small incline or decline? So you're going to have two scales. So this larger dial, and this is what's kind of strange about these, the larger dial is actually going to be the finer measurement. And so the smaller dial, it's usually off to the side, but it would have to be more in the center just because of space considerations. I mean, I'll put it in the middle here. So you're going to have two dials. The small dial is the number of revolutions So what's going on here? You're actually, when we get 90, you're rotating a needle this way, or, oh wait, oh dear, I'm sorry. Forgot we count down again. My apologies. Count down. There we go. So what we're doing, if you revolve all the way around, you're going from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Well, 100 what? Well, what this is, one rotation is 1 millimeter. So the number of revolutions is the number of millimeters. So a full revolution is a millimeter. Now, what happens then is this is divided into 100 parts. So this little dial, when it goes around, it's telling you how many millimeters, whole millimeters that you have. Then the dial on the outside, we're going to take a millimeter and break it up into 100 parts. So we're measuring hundredths of a millimeter on this outer dial. So let me switch over to the the textbook just so you can see it better. So this is what you're going to be looking at. This little dial, it's telling you you've gone how many millimeters, how many full rotations. And then once you get to the last full rotation, you come all the way around and do a little bit of a partial rotation. Now, there's some special meaning, and it's going to be this. The directional arrows here, if you see, I'll close this. A clockwise arrow, and that means it's heading towards the right. This means you have a positive measurement. So you'll see something that looks like this. If you have a counter clockwise arrow or to the left, this is a negative measurement. So if you see something like that. So positive measurement, this means the object, or whatever we're measuring, is larger than desired. And then a negative measurement, the object is smaller than desired. So I'm going to do a couple examples real quick, and then that'll be it for this evening. So let's say we have something like this. And let's say we have our needle is pointing here on the large scale, and then our rotation we have it like this. And then we have an arrow pointing to the left. So first off, let's look at rotations. Now again, we're going to go with a smaller number. So it's 2 revolutions, or rotate, I should say revolutions. Let me use the correct word. Revolutions. So it's 2 revolutions left. That's telling us left. So that means we have negative 2 millimeters. Now we look at the small scale, which is actually the large dial. So we'll go, let's just call it large dial. If you look at it at points at 17. So this is going to be 17 times, and because this is left, it's going to be negative 0.01. And since we've looked at negative numbers, positive times negative is negative point, this would be negative 0.17 millimeters. So adding these together, we'll take the negative 2 millimeters, we'll add the negative 0.17 millimeters, negative 2.17, or 2 1700 millimeters. And questions about that? So I'm going to do one more. I'll do a positive reading. So let's say we have this. So this one's going to be a little tricky. Say we're, let me get my other pen. Let me write it at, this is 40. It's a little not quite to scale. Just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Okay. And then we have our rotation. And let's place our rotation between 0 and 1. And now we've got a rotation to the right. So for revolutions, again, this is our revolutions, and we're going to go with the smaller number. So there's 0. 0 revolutions. So that means so far we have 0 millimeters. Now this is where this gets a little confusing. We're rotating to the right. So that means we're doing this. We're coming around on our large scale. We hit 50. Then when we get to here, this is actually 60 now. And 1, 2, 3, 4. This is going to be 65. This would be 70. So when we come all the way around, we want to remember our numbers are actually going up in value despite how they're labeled. So for the large scale, for the large dial, we'll take 65 times, it's going to be a positive 100th of a millimeter because we're going to the right or clockwise. And so we get 0.65 millimeters or 65 hundredths of a millimeter. And at the end, well, we're going to add 0. That's not going to change anything. That's going to be our answer. So questions about that? So that's it. That's the section on meters, calipers, rulers, and it's a long section. It usually does take a week to go through it, so this isn't really unusual. But that's going to be it for tonight. I posted the videos on the caliper and the micrometers, and so there's one video per device. So if you're working with like a US micrometer, you can watch the video for that. If you're working with a metric micrometer, you can watch the video for that. And the same thing for the US vernier micrometer and also the US vernier caliper. And so those 4 videos are posted if you want to look at those. That could maybe help with the homework. But that's it. Other than that, if any questions, let me know, and have a wonderful weekend.